Atoms of period 3 elements have 3 energy levels. As you move across the period from left to right, the elements change from metal to metalloid to a non-metal. Trends in atomic size and ionization energy. Study the table below, which shows the atomic radii and fast ionization energy of period 3 elements. The atomic radius decreases as you move to the right across period 3 due to increase in effective nuclear charge. The fast ionization energy increases across the period due to increase in effective nuclear charge as you move across the period. Study the table below, which shows the boiling and melting points for period 3 elements. Answer the questions that follow. Sodium, magnesium, and aluminium are metals. Their melting and boiling points are due to strong metallic bonding. Silicon has giant atomic structure with strong covalent bonds throughout. This accounts for its high melting and boiling points. Phosphorus, sulfur, and chlorine have molecular structure, hence their melting and boiling points are low due to weakness of van der Waals forces. Sulfur has relatively high melting and boiling points due to its tendency to have larger molecules. Below is a summary of the trend in electrical and thermal conductivity of period 3 elements. The electrical and thermal conductivity changes from good to poor conductivity as you move across the period. The metals have delocalized electrons, which make them good conductors. The non-metals are poor conductors because they do not have either ions nor delocalized electrons. Reaction of sodium with water. Cut a small piece of the sodium. Hold the piece of sodium using clean, dry pair of tongs. Put in a beaker containing distilled water. Put a red litmus paper in the solution formed and a blue litmus paper. When sodium reacts with water, hydrogen gas is evolved and sodium hydroxide solution formed. Sodium reacts vigorously with cold water to form sodium hydroxide solution and evolve hydrogen gas. The red litmus paper turns blue, while the color of the blue litmus paper remains blue, indicating that the solution formed is basic. Red litmus paper changes to blue, implying that the solution is basic. Reaction of magnesium with water. Cut a small piece of magnesium. Hold the piece of magnesium using dry pair of tongs. Put in a beaker containing distilled water. Dip a red litmus paper and a blue litmus paper in the solution formed. Magnesium reacts very slowly with cold water to form magnesium 2 hydroxide and evolve hydrogen gas as shown by the equation below. The color of the blue litmus paper remains blue, while the red litmus paper turns blue. Reaction of aluminium with water. Reaction of magnesium with water. Magnesium reacts very slowly with reaction of aluminium with water. Aluminium does not react with cold water or steam because it first forms an insoluble coating of aluminium oxide which prevents further reaction. Aluminium will only react with steam at very high temperatures of over 700 degrees Celsius. Reaction of phosphorus with water. Phosphorus does not react with water. Phosphorus is stored in water. This is because it is very reactive in air. Reaction of sulfur with water. Sulfur does not react with water. Chlorine dissolves in cold water to form hydrochloric acid and chloric 1 acid. The solution formed changes blue litmus paper red, while the red litmus paper remains red. Chlorine reacts with water as shown in the following videos. Procedure. To a gas jar of chlorine, add 5 milliliters of water. Replace the gas jar, cover and shake. All the oxides of elements in period 3 except those of sulfur and chlorine are solids. The table below shows the bond types and properties of oxides of elements in period 3. Types of bonds of oxide. Oxides of sodium, magnesium, and aluminium form giant ionic structures, while oxides of silicon forms giant atomic structure. Phosphorus 5 oxide and sulfur 4 oxide forms simple molecular structures. Melting point and boiling point. Oxides of sodium, magnesium, aluminium, and silicon have high melting and boiling point compared to those of phosphorus and sulfur. This is because sodium oxide, magnesium oxide, and aluminium oxide have giant ionic structures with strong ionic bonds which require high temperatures to break. Silicon 4 oxide has giant atomic structure with strong covalent bonds between the atoms which requires high temperature to break. Phosphorus 5 oxide and sulfur 4 oxide have relatively lower melting point and boiling point since they have simple molecular structure with weak van der Waals forces. Nature of oxide. Metal oxides are basic. However, aluminium oxide is amphoteric, that is, reacts with acids and bases. Nonmetallic oxides are acidic. Reaction with acids. Only metal oxides react with acids to form salt and water products. Types of bonding. Chlorides of sodium and magnesium form giant ionic structures. Aluminium chloride is both ionic and covalent, while chlorides of silicon and phosphorus are molecular. The table below shows bond types and properties of chlorides of period 3 elements. Nature of aluminium chloride. Aluminium chloride have coordinate or dative bond. This process is called a dimer.